All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. Okay. So the moment we see option D, we should be able to say that this represents the velocity time graph of an object which is projected upwards from the ground. So all the graphs A, B, C and D we will discuss with respect to the same condition where an object is projected from the ground. Now this explanation may take a bit longer than usual. I would say I think it would at least 10 to 15 minutes of explanation for all the four graphs. Why? Because I'll make sure that every concept is explained, okay, and every graph is explained right from the scratch. So starting with option A. So first the diagram, okay. So an object is projected. It comes to the topmost position, comes back and reaches the same position on the ground again. Now what we need to understand is this is the initial direction of motion. Is the initial direction of motion along the first half. And after the first half, it is the, so I would say after the topmost point, it is the final direction of motion, right? Final direction of motion. What I'm trying to say is the initial direction of motion is towards positive side and the final direction is towards the negative side. Okay. So we need to keep this point in mind. Now, what we'll do is we'll try to understand the velocity and the position relationship. Okay. So let us say this was the initial direction of the object, right? It reaches the top point, then comes down. So the object goes through these positions. See, the key to the very key thing to understand here is at same positions, when I say same positions, I mean towards the upward and the downward motion, speeds remain the same. Okay, speeds remain the same. Those who are listening this concept for the first time, bear with me for a couple of minutes. Your concept will be clear. The idea will be clear. So let me mark these points: A, point B, point C, point D, point E, and point F. All right. And this point, let me call this as A dash, B dash, C dash, D dash, and E dash. Why have I chosen the same letters? Because they both of them are ideally the same point, but they just represent, E represents the upward motion and E dash represents the same point in the downward motion. Okay. Now, if we try to understand this further, let us say velocity at VA is VA, velocity at B is VB, velocity at C is VC, at D is VD, at V is VE. Okay, and velocity of F is definitely 0. But okay, now the velocity as E is V E dash, at V dash V D dash is V dash, at C dash position is velocity VC dash is VB dash is V A dash, right? What we need to understand is, see, every component what we take up towards the upward direction is positive and which comes downwards is negative. So we should write here that this is positive VA, this is positive VB, this is positive VC, this is positive VD, this is positive VE, this is negative VE dash, negative VD dash, negative VC dash, negative VB dash, and negative VA dash. All right. Now, what are we talking about? We're talking about velocity position graph. Okay. So what are the positions here? The positions are A, B, C, D, E, and A dash, B dash, C dash, D dash, and common position F. Okay. What are the corresponding velocities? VAA, VBB, VCC, VDD, VE. Okay. Now I'll take a numerical to explain you this further. So if I make use of a numerical, say it comes like this. Okay, why numerical? I'll tell you that also. I can actually directly correlate the graph with respect to this data itself, but I want to go to a numerical because only then you'll be able to understand graph C and graph T. We will come to that. So let us say the object was projected with velocity 10 meter per second. So I must write here plus 10. See, as the object is thrown upwards, the speed will definitely reduce down, right? Because you're pushing it against the gravity, so the speed will come down. Which means after some point, it will be 9 meter per second. Example, okay? Plus 8 meter per second. So this is velocity. Plus 7 meter per second. Plus 6 meter per second. And say eventually 0. When it comes down, it will be at the same height, it will be minus 6 meter per second. It will be minus 7. Why is it increasing? Because downward direction, acceleration due to gravity is acting. It is acceleration, it will increase the speed. Okay. So it is minus 7, minus 8 meter per second, minus 9 meter per second, and minus 10 meter per second. All right. So the corresponding positions, I'll take the same positions again, which is at position A, at position B, C, D, E, and F. This is E dash, this is D dash, this is C dash, this is B dash, and A dash. Okay. Right. Now, if we try to plot the graph, what do we get? Let us see. Velocity, position. So this is plus V, this is minus V downwards. What are the positions? The positions are A, B, C, D, E, and F, right? And of course, A will overlap with A dash, B will overlap with B dash, C will overlap with C dash, D over D dash, E dash, and F dash. Now the velocity I've taken it from 10, 9, 8, 7, 6. Okay, so let's say this is 6, 7, 8, 9, 10, minus 6, minus 7, minus 8, minus 9, and minus 10. See, what is the first point, the first coordinate? The first coordinate is A, comma 10, right? What is the second coordinate? Second coordinate is B, comma positive 9. The third coordinate C, comma positive 8. All right. So just let us plot that A, comma 10. So okay, I think I should make a small correction in the naming here, because it should be A from here itself, right? A, B, C, D, E, and F. All right. Now, when the position was A, the velocity is 10 plus 10. So this is 1 point. This is 1 point, A, comma 10, right? When second coordinate is B, comma 9. So when the object is at B, the corresponding velocity is at 9. So this is B, comma 9. What is the third coordinate? Third coordinate is C, comma 8, right? C, comma 8. Now I don't need to explain it further. What will be for D? It will be D, comma 7. For E, it would be E, comma 6. For F, it would be 0. Now, again, when it comes to E dash, it will be negative 6, D, negative 7, negative 8, negative 9, and when it is A dash, it will come to 10 again. So if you draw the curve, what you get is such a shape, right? Which coincides with what is given in option A, and therefore option A is correct. All right. So that is the explanation for the graph A. Now let us see the relationship with the graph C, which is actually the position time graph, right? Position time graph. So let's draw it here. The position time graph of this object. Now, how do we understand this? By using the same reference diagram, right? So, mind you, it's position time graph. Okay. So, the object is projected, maximum height, comes back. Let us say at t is equal to 0. At t is equal to 0, the object was here. Okay. At t is equal to 1, the object is here at A. At t is equal to 2, the object is here at B. At t is equal to 3, the object is here C. Then at D. At t is equal to 4, it is at T. At t is equal to 5, it is at C dash. At t is equal to 6, it is at B dash. At t is equal to 7, it is at A dash. All right. And at t is equal to 8 again, it comes to the origin, ground again. Okay. So now if we try to plot the graph, what do we get? Let's see. So what are the time coordinates? We are taking it as 1, 2, 3, 4, 5, 6, 7 and 8. And positions, we are taking it as A, B, C and D, and then A overlaps with A dash, B dash, C dash and D dash, and of course O. O and O dash will overlap. Now, what is the first coordinate here? 0, 0, which is this position, right? Second coordinate here, 1 and A. So we have 1 and A. Third coordinate is 2, B, right? This is 2, B. Now repeating the same should be your responsibility. The fourth coordinate would be exactly. The fourth coordinate should be fifth coordinate would be, sixth would be, seventh would be, and again 8 would be, which means we get a graph like this, right? So option C is also correct. The position time relationship is also correct here. Now, if you try to understand this in the mathematical part of this, see, what is the displacement time relation or the position time relation is given by S is equal to ut plus half at square, right? So S is basically u with ut plus half into A here is minus g into t square. So S is ut minus half gt square. Basically what does this represents? This represents that the position time relation should be what in nature? Should be a parabolic curve in nature. Now, is the position time given to be parabolic in nature? Yes. So that is also another way of saying that, having a look at the same graph. Okay. All right. Now, moving on to the option B, which is distance time relationship. Okay, not position time. This time it's distance time. All right. So when we discuss about distance time relationship, where do I draw this? Okay. So let me try to explain distance time relationship now. Distance time relation. Okay, this time what we'll do is we'll try to understand the graph mathematically. Okay, so the curve is, this is distance here, this time here. The curve is given roughly something like this, right? Now see, what is slope of the tangent is equal to? Slope of the tangent is equal to change in y-axis by change in x-axis, which here is change in distance by change in time, right? Change in distance by change in time. Now, what is slope is equal to? So slope is equal to dy by dx, which is here is d by dt of distance, which is nothing but velocity, right? Which is nothing but velocity. Oh, sorry, it's displacement, right? So it is nothing but speed. So the slope here will give you the magnitude of speed. Let us try to understand the graph. See, if you draw a tangent here, it will go like this, right? If you draw a tangent here, come like this. If you draw a tangent here, go like this, like this. So let me call these points as point A, point B, and point C. Okay. So I can write from the graph that slope at A is greater than slope at B is greater than slope at C. Direct inference from the graph, right? Now, when slope of A is greater, what is slope? Slope is speed, which means speed at A is greater than speed at B is greater than speed at C. Which means the graph is trying to give an impression that as time increases, speed also increases, right? But let us now have a look at the speed time relationship here. See, here what you can see is as time increases, speed actually decreases first 10, 9, 8, 7, 6, and then as time increases, the speed increases further. Okay, so if we write it down, we can say that during the upward motion, right? During the upward motion, speed actually decreases, but during the downward motion, what happens? So what happens during downward motion is that speed gradually increases. But this graph gives us an impression that speed always is increasing, and therefore this is a wrong representation of the graph. So the correct option here is to pick it incorrectly, which is option C. Now, let us discuss option D also. So, option D is velocity time relationship. Okay, so if we try to understand the velocity time relationship, let us have a look at that also. Velocity time relationship. Now we'll do both analysis here, mathematical as well as the graphical part. Okay, so the object is projected, right? It reaches the maximum height. It then comes back to the normal position, back to the ground. We know that the velocity is, say, plus 10, plus 9, plus 8, plus 7, plus 6, plus 5. And then when it comes down, it is 0, negative 5, negative 6, negative 7, negative 8, negative 9, and negative 10. All right. So let us assume this is at t is equal to 0, t is equal to 1 seconds, t is equal to 2 seconds, this is t is 3 seconds, this is t is 4 seconds, this is t is 5 seconds, this is t at 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds, and 11 seconds, followed by, wait, did I go wrong? 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, 12 seconds. All right. 0, 1, 2, 3, 4, 5, 5, okay. 1, oops, sorry. 0, 1, 2, 3, 4, 4, this is 5, then this is 6, 5 is 7, 6 is 8, 9, okay, all right. Now, what we can see from the graph here is, this is velocity, this is positive velocity, negative velocity, and time, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, have a look at this. The velocity, okay, let me write down the velocity also. 1, 2, 3, 4, 5 velocities. We should be starting from 10, right? So 10, 9, 8, 7, 6, 5, 4. Okay, so 5, 6, 7, 8, 9, and 10. We have minus 5, minus 6, minus 7, minus 8, minus 9, and minus 10. So what is the first point? 0, comma 10. All right, 0, comma 10. Second point is 1, comma 9. So at 1 seconds, the velocity is 9. Then it is 2, comma 8. It's here. 3, comma 7. Like this, like this, like this. And eventually it's at 0, right? Eventually it is at 0. So this is the graph you obtain. Now what does this represent? This represents the first half of the motion. And what happens in the second half is that the velocity goes further like this and eventually comes to this point. So what is the second? This represents, below this is the velocity time graph during the second half of the motion, or that is the when the particle is coming downwards. Now let us have a look at the diagram. Look at the graph given. Is it the same graph given? Yes. So this is also the correct representation. Now, trying to understand this in a mathematical way. If you try to understand this graph in a mathematical way, and if you are being asked to find out whether it is right or wrong, how will you do that? See, if we understand that during the first half, this line represents a negative slope, right? What is negative slope implies? Negative slope implies that the dv by dt is negative. The change in y-axis by change in x-axis is negative. What is dv by dt? It is acceleration. So it is acceleration is equal to negative. Is it true? Yes, because when the object is projected up, acceleration is equal to minus g. So yes, that part is correct. Now, this simply gives a correlation that since a is minus g, what happens is the velocity will be given by the relation v is equal to u plus at, which is basically v is equal to u plus minus gt. Therefore, v is equal to u minus gt, right? And now if you try to understand with the mathematical part, this can be written as y is equal to c plus mx, right? So x is the t coordinate here, x is time here, y is velocity here, it is given. In which case, what is c? C is the initial velocity, which is the intercept. So this much distance is the initial velocity. Yes, it is u. And what is the slope? The slope is minus g. The slope of the tangent is minus g. It resonates with the given graph, and therefore option D is also correct. So I think I have given every possible explanation, mathematical as well as physical, using a diagram for every graph possible. This should be, I think there's no point in skipping the explanation. So I think I've given the comprehensive explanation. If there is any doubt which you feel should be addressed, please feel free to ask. I'll give a better explanation if possible.